The fourth reaction that we'll learn today is the double decomposition reaction. So as the word suggests, we have two compounds and both the compounds decompose to form two new compounds by exchange of radicals. So a chemical reaction in which there is exchange of ions between the reactants are called double decomposition reaction. Double decomposition reaction in reality are of many types, but you will see mostly two types of double decomposition reaction, of which the first type is called precipitation reaction. Reaction between two compounds in aqueous solution state to give two new compounds of which one is insoluble solid, and this insoluble solid is called the precipitate. Okay, an example of precipitation reaction we have already done before when we were discussing about the balancing of equation. The second reaction that we saw, that is PbNO3 lead nitrate aqueous solution along with potassium iodide aqueous solution, provides lead iodide as a solid and potassium nitrate as an aqueous. So this is an example of precipitation reaction. Another example of precipitation reaction, Na2SO4 aqueous plus BaCl2 aqueous gives BaSO4, that is a solid, and 2NaCl, that is aqueous. So this solid that is produced is basically called the precipitate. So as you can see over here, what is happening is there is exchange of ions between the reactants. Sodium was with sulfate ion and barium was with chloride. Now barium comes with sulfate and sodium goes with chloride. So barium sulfate and sodium chloride is produced. So the reaction is balanced. This is another example of precipitation reaction. And this barium sulfate is white in color. You will also need to remember the colors of this precipitates. The barium produces precipitate that is white in color. Okay. And the second type of double decomposition reaction that we see is neutralization reaction. Neutralization reaction, we have also seen in our junior classes what neutralization reaction is. Basically what happens is that acid and base, they react to give salt and water, and this takes place by the exchange of ions or radicals. That is why it's called neutralization reaction. And this neutralization reaction is a double decomposition reaction. Reaction between acid and base to give salt and water by interchange of radicals. For example, say NaOH, this is a base, reacts with HCl and an acid to give NaCl, with sodium chloride goes and hydrogen comes with OH. So HOH basically means 2 hydrogen and 1 oxygen, that is water is produced. So this neutralization reaction is also an example of double decomposition reaction. Okay. As you can see in the example that we discussed earlier while balancing the equation, this equation, lead was with nitrate and potassium was with iodide. After the reaction, the lead comes with iodide and potassium goes with nitrate. So this is also an example of double decomposition reaction. Now the next topic, fifth one, is the oxidation and reduction. Before starting this, let's understand the difference between what oxidation and what reduction is. Okay. Oxidation, as the word suggests, is the addition of oxygen. So reduction, just the opposite, is the removal of oxygen. Now, if you recall from periodic classification of elements, we learned that an element, when it gains atoms of an element that gain electron to become stable, are called electronegative element. They always try to gain electrons and gain negative charge, hence are called electronegative element. So addition of oxygen can also be related as addition of electronegative element, and removal of oxygen or removal of electronegative element. The second point, oxidation, as it is addition of oxygen, we also relate this with removal of hydrogen. And if oxidation is removal of hydrogen, reduction is addition of hydrogen. Hydrogen is in group 1. Group 1 elements have a 1 electron in their valence shell. So they lose electron in order to become stable. So as hydrogen loses electron to become positively charged, hydrogen is an electropositive element. So we can correlate removal of hydrogen with removal of electropositive element. And addition of hydrogen as addition of electropositive element. And the third and the last point, oxidation and reduction, Reduction is the addition of electrons. In equations where electrons are added, we say that reduction has taken place, and removal of electrons is oxidation. Okay. So now let's look at some example. Say we take some copper plus oxygen. So we are basically doing combustion of copper. So copper, when it reacts with oxygen, it forms CuO, copper to oxide. This is a black in color. But that's not the main point here. What is the main point is that here copper gets converted into CuO. So copper is basically gaining oxygen. So a gain of oxygen or addition of oxygen is basically or oxidation. Now if we look at oxygen to CuO, now oxygen to CuO, we are gaining a copper atom. So copper is a metal. Metals are electropositive in nature. They tend to lose electron in order to form ions. So copper is an electropositive metal. So oxygen to copper oxide, we see that we are gaining electropositive element. Addition of hydrogen or electropositive element is under reduction. So oxygen to copper oxide is reduction. So this is how we find what is oxidized and what is reduced. Next example, copper oxide reacts with hydrogen gas, and when heated, this also when heated forms Cu plus H2O. So as we can see, from this one, copper and hydrogen is more reactive as compared to carbon. So what hydrogen is doing is, hydrogen is displacing copper from its place. So this is an example of displacement reaction. Now this reaction, how will we see which is getting oxidized and what is getting reduced? Copper oxide to copper, what is happening is it's losing oxygen. Removal of oxygen is basically reduction. So this is undergoing reduction. And hydrogen to hydrogen water, this is a gaining oxygen. So gain of oxygen or addition of oxygen is oxidation. So this is how we find what element got oxidized into what, and what element or compound got reduced into what element or compound. Now next example, ZnO plus C gives zinc plus CO. So here zinc oxide is converting into zinc, that is removal of oxygen. So this is reduction, and carbon is gaining oxygen. So this is oxidation. Next example, magnesium oxide reacts with hydrochloric acid to give manganese chloride plus water plus chlorine. So here what is happening is our HCl is getting converted to Cl2. So there is loss of hydrogen. A loss of hydrogen, removal of hydrogen is oxidation. So this is oxidation. And from MnO2 to MnCl2, oxygen is getting removed. So removal of oxygen is a reduction. So this is Here we see that manganese oxide gets reduced to manganese chloride and hydrochloric acid gets oxidized to chlorine. The last topic in the chapter now. Okay, before that, in every reaction, as we are seeing, there is reduction as well as oxidation. So these reactions in which reduction and oxidation takes place simultaneously, we call this reaction as oxidation reduction reaction or simply redox reaction. Reactions in which one reactant gets oxidized and the other gets reduced simultaneously is called oxidation reduction reaction or redox reactions. Redox reactions basically is a reaction in which oxidation and reduction takes place simultaneously. Now we come to the last topic of the chapter, that is corrosion of some metals and rancidity. What happens when substances that we use in our everyday life gets oxidized? So first is corrosion. Now when a metal is attacked by substances around it, such as moisture, acids, etc., it is said to corrode and this process is called corrosion. Example, very commonly we see that there are rusted iron everywhere. So that rusted iron is also an example of corrosion. So metals, what happens is it is attacked by moisture and oxygen, because of which your iron converts into this reddish brown powder. So that is the rusting of iron. Reddish brown powder on iron articles, that is basically rusting. And then the black coating on silver. Silver reacts with atmospheric gases and converts into black substance. And green coating on copper are examples of corrosion. Now, because of this corrosion, what happens is there is a very serious issue. The railway tracks, they need to be replaced, and ships, they are made up of iron. So they also, as they get rusted, they become weak. So we need to replace tons and tons of iron every year. So that costs a lot of money, and corrosion is a very serious problem. And rancidity. So in food particles, basically when fats and oils are oxidized, they become rancid and their smell and taste change. So usually what we do is, in order to prevent a rancidity, we have say packs, this chips that we buy, they are flushed with nitrogen gas inside, so that it prevents the food particles that are there or the chips that are there from getting oxidized, so they does not become rancid. So usually substances that prevent oxidation that are antioxidants are added to food containing fats and oil. So this is also the reason why chips manufacturers flush bags of chips with nitrogen gas to prevent chips from getting oxidized. So flushing the bags of chips with nitrogen helps prevent the chips in coming contact with oxygen. So if it doesn't come in contact with oxygen, they do not get oxidized and they remain fresh for a longer period of time. So with this we complete the chapter. You are expected to complete all the in-text questions and exercise as your assignment. Thank you.